Here we are. So, next talk. Um, we already talked about databases in the morning to compare active record with a potential alternative. But I don't know how many of you have dug into the innards of active record. There's plenty to understand in there. Um, so let's welcome Eileen for our next live talk. Hello, Eileen. Nice to see you again.
Hi, nice to see you too.
Hi.
It's really weird giving a talk live from home.
I know, right? To
Okay.
some degree, it feels very intimate and very comfy, but also it's like, people are looking at me. This is they're in my house.
Yeah, totally. Okay.
Yeah.
So I can start now, right?
Yeah, right on if you
Okay.
want.
Cool.
See you
All
later.
right. Awesome. Hi, everybody. Ciao, buongiorno. Hope I didn't totally butcher that pronunciation. I just started learning Italian when I was first asked to keynote Rubyday, and I had challenged myself to learn some, but I don't know enough to give a whole talk in Italian. I'm hoping that I get to go to Italy one day and actually see if I understand everything that I've learned. I'm Eileen Uchitelle, and I'm a staff engineer at GitHub. I work on improving Rails and Ruby to help GitHub meet our scaling, reliability, and usability goals. I'm also a member of the Rails core team. We're responsible for deciding the future of the Rails framework, when new releases should come out, and what features we want to build and support. If you want to get in touch with me, you can find me anywhere online at the handle Eileen Codes. Welcome to my talk called Technically a Talk. This title is a little bit of a joke. It's a play on how technical this talk is, but you'll also see that it's so much more than just a talk. Today, we're going to deep dive into how to use multiple databases, the design and architecture of the APIs, and how connection management works internally. When I first started working on this talk, I mapped out every single pull request and commit that I was involved in that implemented multiple database support. I was impressed to find that over time, we had amassed over 100 pull requests that added the functionality Rails needed to support database scalability and growth. We did work to improve migrations, we improved database configurations, we built out and improved Rails tasks, we built easy-to-use APIs for establishing multiple connections, and we built an auto-switching middleware. As I look at this timeline, I don't just see years of work. Instead, I see how much I care about this framework and our community. So while this is technically a talk, it's also so much more than that. This talk, as well as this timeline, represents my love letter to Rails and to the community. I started working on multiple database support 2.5 years ago. There were a few third-party gems that provided solutions, and at GitHub, we had actually written our own internal code for handling multiple databases. From my experience working at GitHub, I knew that supporting multiple databases in Rails wasn't just a nice to have. It was a requirement for Rails' continued success as a modern web framework. We have to continue to improve the foundation that Rails provides for applications so that companies that were built on Rails can mature and grow on Rails for years to come. GitHub is one of Rails' many success stories. We weren't successful in spite of Rails. We thrived because of it, and also because of the changes that we made to be able to continue using it as we grew. There were many good reasons for us to upstream our database code to Rails. It meant we could delete thousands of lines of code from GitHub. This would make our code less complex and more modern and more resilient. But more than that, it meant that we were finally sharing what we had built for Rails with the rest of the community. And today I'm going to share that work with you. We'll first talk about what I mean when I say multiple databases. Then we'll look at how to set up your application. And then we'll dive into how architecture and design works. When I talk about multiple databases, I'm talking about the ability for your Rails application to connect to, write to, and select from more than one database in a single environment. In a standard new Rails application, there is one database per environment. The database for the current environment traditionally holds all of your tables your application needs. As an application grows, the database will become too large to effectively handle the data and traffic it needs to support. When that happens, there are many ways to alleviate pressure on your database. In this talk, I'm only going to focus on the 3 ways we now support in Rails. One way of breaking up your data is to use horizontal sharding, also known as horizontal partitioning or multi-tenant sharding. Horizontal sharding is when you take your database and horizontally split the tables by row. With horizontal sharding, each of the partitions of your database contains the same schema but different data. This approach is focused on limiting the number of rows in each shard or partition, therefore reducing the number of rows that need to be indexed and then selected from. Another way of splitting up your data to alleviate pressure on your database is with functional partitioning. In this method, tables are split by function or need rather than by row. Functional partitioning means splitting whole tables into separate servers or clusters rather than a set of rows. Each partition has a unique schema or different schema. This method focuses on moving high-volume write tables out of your main database cluster into their own clusters to alleviate pressure on that main database. Both of these types of database partitioning can also support read replicas. Replicas are copies of the primary writer database that are used to reduce pressure on the writing database for read queries. The goal is to send as many read queries, like selects, as possible to the replicas. Now that we have an understanding of what multiple databases are, we can look at how to set them up in your application. If you watched my RailsConf keynote, this used to be a demo, but I cut the demo because we only have so much. We have less time, and I wanted to make sure that we got through everything. In the following slides, we have a recipes application. The application has one primary database that contains tables such as users. It is a second database called meals that contains recipes. The meals database has 3 shards, and the default shard, which contains the shard keys that are used to look up data from the other 2 shards, and those 2 shards contain all of that content. Both the primary and meals database have replica databases. In order to implement this database setup, we need to include the databases in our configuration file. To do this, we add a new tier to our database YAML, and then add an entry for each of the writers and each of the replicas our database requires. This example has been simplified in order to fit on the slide. Once we have our configurations, we can run the rake tasks like a standard Rails application. Create, drop, migrate, all of those will work. And the only thing we need to do is to set up our connection classes. The primary connection for our application is used for models that inherit from application record. We need to update the existing application record to be aware of both connections by using the Connected2 API. Additionally, we need to implement a new abstract class for our sharded models. Now, any model that inherits from meal application record will use these databases rather than the primary. And that's it. That's all your application needs in order to use multiple databases. We haven't yet looked at how to switch shards or roles, but even without that, your application is all set up to read and write from more than one database per environment. We'll look at how to actually switch connections later on. But first, I'd like to take a look at the architectural changes that we needed to make for Rails to support multiple databases. At GitHub, we'd written our own code for handling multiple databases that had monkey-patched an extended active record. Once I had a handle on what was broken in Rails and needed to be fixed, I built APIs in Rails that were inspired by our code at GitHub. I changed the APIs a fair bit to better match Rails style, but effectively the internal code behaves the same. This approach to building functionality is a little unique because I built the public-facing code first and fixed internal second. This might sound backwards, but it allowed me to architect changes based on real-world applications rather than build for a perfect but unnecessary use case. In Rails, we focus on building easy-to-use, simple, and functional APIs that are focused on user experience. Our goal is to optimize for your happiness. The Rails internals take on complexity so that you can focus on building your application. One of the first places that we improved the user experience for multiple databases was with migrations. The Rails migrators and other tasks now understand how to work with multiple databases. The scaffold model and migration generate commands can take a database argument. This argument will look up the migrations paths that you set in your database. For sharding, we want to use only one directory and migrate that multiple times so we can set each of the entries to use the same migrations path. We're not going to dive into the internal changes for migrations that allowed for this to work because I talked about that 2 years ago at RailsConf 2018. The migration internals haven't actually changed since this talk. So if you're interested in that work, you can watch this talk on Confreaks or YouTube. On the other end, one of our biggest architectural changes to Rails was to turn database configurations into objects internally. Previously, database configurations were simply nested hashes. These hashes had made sense and served us well when applications used just a 2-level config. Rails would parse the database YAML and turn it into a 2-level hash. It was easy to find the right configuration because it always corresponded to the current environment. If we're in development, there's only one configuration that can possibly be selected for development. Because of this, many Rails internals assumed the connection configuration could always be found by looking up the hash associated with the environment key. However, when Rails introduced a 3-level configuration to support multiple databases per environment, it increased the complexity of the generated hash and broke many of Rails' internal assumptions. When an application boots, it has to connect to a database. That's required. So Active Record includes a rel tie that establishes a connection to the configuration for the environment. But if we have 2 or more configurations per environment, how does Rails know which one to connect to by default? We can't assume non-replicas because in a multiple database application, there could be more than one writing database per environment. At GitHub, we actually have 12. In addition to how can Rails know we have a 3-level configuration, and how do we use that configuration to create named Rails tasks for each of the database entries? Constantly parsing hashes to figure out where we are in the stack is possible, but error-prone, brittle, and introduces unnecessary complexity. We wondered, what if we could parse the hash just once and know everything we needed to know about all the configurations after the app was booted? This led us to introduce a new database configuration object. The idea was that we could parse the configurations once and then be able to more easily select and enumerate on the objects that were created. Once the hashes became objects, we know everything we need to know about the configurations, like what environment they belong to, their name, and their connection requirements. The database objects look like this. There's an env name, an identifier name, and a configuration hash. Each of these corresponds to the first, second, and third level of the YAML, respectively. If you're using a URL configuration, Rails will generate a URL config instead of a hash config. The only difference is that the URL config includes the original URL that was passed. Database configuration objects get generated by Rails when the application is booted in an active record initializer. This configurations method instantiates a new database configurations objects, which loops through all of the hashes and turns them into objects. We're not going to dive into build configs method because it's really not that interesting. The result returns an active record database configurations object that contains an array of configurations. These objects make it easy for us to iterate, enumerate, and select correct configurations from the list without parsing a 3-level hash multiple times. Now that we have the configurations objects, we can ask Active Record for all of the configurations for an environment with the configs for method. This is really similar to using a hash and will return a list of configuration objects for the production environment. We can also get configurations for an environment by name. Env name production and name meals will return one matching configuration object for those parameters. By default, replicas are excluded from the configurations returned by configs for, since in general, you actually don't need to do anything with the replicas. You're not going to create, drop, or migrate the databases. Their name is the same, so they should be using the same, right? The same as the writer database, and so your database will already be created. Otherwise, we would need to implement a feature that synced data between the primary and replicas locally, and that's a huge pain. If you need to get replicas from the configurations list for any reason, you can pass include replicas true to configs for. These database configuration objects make it easier for Rails to interact with the database configurations. Once we have the objects working correctly for creating the Rails tasks and the configurations, we started working on the internal API. We wanted to ensure that all of the methods internally in Rails use these database configuration objects to make it easier for Rails internals to interact with the database configurations. Sorry, this slide is wrong. Okay, whatever. Rails was still internally in Rails, we were still using the configuration objects everywhere. But we wanted to make sure that Rails was never reaching into the configuration hash. The objects include the hash. We should never ask the hash for something that the object can return itself. So in order to accomplish this, we needed to identify everywhere that we were accessing the hash and add reader methods for those. This was required because we didn't want to change all the hashes to configurations and have to access the hash directly anyway. Instead, we wanted to be able to get all the information from the objects themselves. In short, we needed to be able to ask dbconfig directly for its database. To accomplish this, we needed to look at where we were using the configuration hash and figure out what keys in the hash were values Rails needed to access and which were values the client needs. Said more simply, Rails should never have to reach into the hash stored on the database config for values. It should always be able to ask the object directly for the data it needs. For each value that Rails needs, we added reader methods to the database configuration objects. This lets us remove all the hash accessors in active record and turn them into real accessors. So here's an example of an internal change in Rails. By moving to using objects everywhere, we ended up with cleaner code and a single place to set defaults. The configuration objects have really been useful for improving the internal code in Rails, and they were really instrumental in features like generating the Rails tasks. Active Records database tasks are super important to having a good development and testing experience. Without them, you would need to run lots of manual SQL queries just to get your database set up. Even if all the Rails internals supported multiple databases, the feature would be a failure without supporting Rails tasks. Rails tasks make using Rails applications enjoyable. They do the hard work for you. The database tasks, the database objects were instrumental in creating these tasks because they allowed us to enumerate on, find, and select database configurations that we needed to generate those tasks. So the first thing we did to support multiple databases in the Rails tasks was to update the existing ones to operate on all databases for an environment. To do this, we updated the tasks to use the database configuration objects. This is an example of the migrate task. First, we looked up the configurations for the environment and return an array of database configs. Since configs for doesn't return replicas by default, we know all of these objects are for the writer databases that need to be migrated. If we returned replicas, we would just end up raising errors because replicas should have a read-only user. We then established a new connection using the database config object. Since Rails tasks don't boot the application and don't know what models to use to run the migrations, we need to establish a connection so that we're connected to the correct database when running these tasks. Once connected, Rails calls migrate. Lastly, we reestablish a connection to the original configuration so we don't accidentally have active record base connected to the wrong database when migrations are done. In addition to supporting all the tasks with the original database tasks, we added tasks for each of the databases as well. Creating these tasks looks really easy, but it was actually a lot more difficult than I anticipated. So if we look at the code that generates the named migrate tasks, you'll notice that, oops, I went forward too many. Okay, there we go. We notice that we have a method named for each before loading the configuration. The configuration objects are generated when load config is called, but we needed to access the names, so like primary meals1, meals2, before we loaded the environment. Since the database configurations allow applications to add ERB and other environment-specific configuration into the YAML file, if we were to load the database YAML before the environment, we'd get an exception. If we loaded the config to generate the tasks, Rails-T would have taken a dramatic performance hit. So you had to figure out a way to parse the YAML without evaluating any ERB or loading the entire application. To do this, we created a special YAML loader in Railties that parses the ERB with a special class named dummy ERB. This class has only one job, and its job is to replace any ERB in the YAML with an empty string. This gives us database configurations that are absolutely not suitable to connect to your databases, but provides just enough information to have the environment name and configuration name available to generate the named tasks. Once we call load config, we can look up the real configuration objects because the environment will already be loaded. This lets us avoid a performance hit on generating the task names, but we still get everything we need for multiple databases. One of my favorite features of multiple databases work that I did is the connection APIs. These are simple APIs for establishing connections and swapping connection contexts. They are what powers multiple databases. The Connected2 API enables you to establish more than one connection on your models. This method is very similar to establish connection, except for that you need to specify the type of connection and the database configuration at the same time. In a single database application, you don't need to call establish connection in your application code. Rails does it for you in an active record rel tie when your application is booted. If you're using multiple databases, we need to tell Rails there are other connections that need to be established. Depending on the types of connections we need, there are 2 ways to establish connections with Connected2. If you're using functional partitioning with a single primary and a single replica, you should pass database to Connected2. The keys in this hash represent the role names that you want your connection to have. By default, Rails expects you to set primaries to writing and replicas to reading. The second part of the hash represents the database configuration names you want to use. These must match the second tier of your database configuration exactly in order to set up the connections properly. Connected2 should only ever be called on abstract classes. Database clients have a limited number of open connections they can have, so you want to ensure that you're only establishing each connection once. Always set up your connections in an abstract class and inherit models that need to talk to that database from the parent class. You can also connect multiple shards and roles. The shards keyword argument. Shards and database arguments do not work together. You have to use one or the other. Default shard 1 and shard 2 represent the shard keys. You must name one of the shards default. If you don't, Rails will create one for you and you'll end up with duplicate connections. All the other shards can be called whatever you want. The default shard should be the shard that contains references to the other shards so that you know which shard key to look up your data by. Just like the database argument, the hash for each shard represents the role and database configuration name, respectively. Once you have an active connection, your application models will need to be able to switch between roles and shards. We provided that functionality with the Connected2 API. This API enables you to switch between shards or roles in a model controller scripts anywhere that you need to change the connection context. If you want to use the Connected2 API, you can select data from your replicas by switching the role to reading. This will now select data from the reading pools. The connection itself is actually chosen by the model we're loading, like user or dinner recipe. Rails knows that user inherits from application record and dinner recipe inherits from meal application record, and will use that to pick up the correct connection from the reading pools. If you try to write data from the reading role, Rails will raise a read-only error. This will happen regardless of whether replicas have a read-only user. In addition, Connected2 can take a prevent writes argument, which will raise a read-only error on any role for you. This may be useful if your app is just getting started with multiple databases and you want to ensure that you're not writing when you mean to read before you get your replicas set up in production. This is also useful if you're using a role named something other than reading but still want to block writes. Switching shards with Connected2 is as simple as passing the shard key with the shard name you want to switch. The shard key behaves similarly to the role key by looking up connections from the pool based on the context set and Connected2. If you only pass shard and don't pass role, then Rails assumes that you want the writing connection. Switching to the reading connection is as easy as calling role and shard together in Connected2. So let's take a look at how these connection contexts work internally in Rails. In a single database application, we have a single connection handler. By default, Rails always has a writing role. The writing handler looks up connections by class name. In Rails 6 and below, the class name lookup for active record base was set to primary, but in 6.1 we changed it to match the class name since all other connections are looked up by class name and we want to be consistent. The class name is mapped to an object called pool config. The pool config holds a reference to the connection specification name, which is a pointer back to the class cache key. So that corresponds to active record base. The DB config, which is the entire database configuration object that belongs to this pool, and the schema cache. Lastly, the pool config points to the connection pool itself, which is another object holding a bunch of other stuff. When you call a model in one of the meals databases like dinner recipe, Rails looks up the connection based on the parent class name, which for dinner recipe is meal application record. As with active record base, the class references the pool config, which references the connection pool. When you switch connections from the writing to reading roles, Rails is able to look up the connection the same way it did on the writing handler. We first switch the reading handler, and then Rails is able to look up the connection from the pool based on the parent class name. Since Rails knows how to find the connection based on class name, it's simple for it to find the connections from the pool once we switch the context around. Looking at this example, you may be thinking, how can this possibly support shards? For always keying connections on the class name, then adding a second and third shard with the same class name would make it impossible to look up the correct connection when we swap shards. How can we look up the correct connection when there's no unique identifier? Well, you're right. This is the exact problem that was the blocker for adding sharding to Rails. To fix this, we decided to create a new intermediary object called pool manager. Instead of pointing the handler to the class and then to the pool directly, and then directly to the pool config, we changed active record to have the class point to a new object called pool manager. The pool manager holds the shard key names passed into Connected2. For non-sharded connections, we always use a key called default. This way we could maintain backwards compatibility behavior for non-sharded applications, and then still allow for multiple connections for shards in a single class. This intermediary allows us to use a public API for sharding, and we were able to solve this without breaking any public APIs that your applications are already using. Don't worry if you didn't follow this too closely. You don't need to know how any of this internal architecture works to be able to use multiple databases in your application. Another multiple database feature that Rails provides is a middleware for automatic connection swapping. Currently, only role swapping is supported. Sharding support should be coming soon, but I've been saying that for months. We just haven't gotten around to it. The automatic role swapping middleware switches the connection context based on the request type and how recent the last write was. The middleware is designed to guarantee read your own write, which means that if you write data, we guarantee you'll be able to read it because we send your requests to the primary until it's safe to send them to the replica. It does not guarantee immediate writes for any user who didn't perform the data update. The middleware can be activated by the Rails configuration. By default, Rails will use a 2-second delay before switching read requests back to the replica after a write to account for replication lag. You can change this to any number or calculation that works for your application. For more advanced requirements, any of the classes in the middleware can be customized or overwritten. They're actually designed to be monkey patched. Internally in Rails, the database selector is initialized with an app resolver class, context class, and options. The resolver class determines which database role to switch to, and the context class is the context in which we switch. By default, the context for switching is stored in a session. When a request begins, the select database method is called. In this method, Rails checks whether the request is a reading request. Those are head or get requests. If it is, we'll call resolver read. Otherwise, we call resolver write. The resolver read method checks whether it's safe to read from the replica or not. Read from primary checks if the time since the last write is okay. This is calculated by the context timestamp, which is stored in the session, subtracted by the current time, and asks if it's less than or equal to the delay. The delay is set by the middleware options, and the default is 2 seconds. If time since last write is not okay, then we read from the primary or the writer database by passing the writing role to Connected2 and ensuring that writes are prevented. If time since last write is okay, we can call read from replica, which uses the reading role. Lastly, if we have a non-reading request and are performing a put, patch, post, or delete, we call write to primary with the writing role and prevent writes set to false. The write to primary method also updates the context's last write timestamp. The timestamp is used to determine when the last write occurred, so the read from primary conditional can determine whether we're safe to read from the replicas. As I mentioned before, the middleware is meant to be extensible, changed, or overwritten to match your application's needs. If you prefer to use a cookie for your context, you can write your own cookie class in your application and then simply update the Rails configuration to use the new class in the middleware. The middleware was designed to be a guideline for implementing automatic connection swapping in Rails. It's purposely compact and doesn't do everything your application will need. Because replication lag and other issues with database traffic are unique to your application, we created something that provided a guide for automatic swapping without strictly forcing you to use Rails defaults. Before we get into the last portion of this talk, I'd like to take some time to say thank you to some folks. First, I want to say thank you to the organizers for inviting me to speak at Rubyday and providing a platform for us to share our presentations. Next, I'd like to thank the 2 people who helped most with these features. They're Tenderlove and John Run. Funny enough, both of them are speaking today too. They were both instrumental in helping me build these features. The database caches to configuration objects was actually Aaron's idea. I also blame him for the dummy ERB class. And John helped me with fixing so many bugs that I created in connection management, and the pool manager for sharding was his idea. And lastly, I want to say thank you to all of you watching at home. While it's sad that we can't be in a room together, I'm glad that I was still able to share this experience and talk with you. So when I first started working on multiple databases, I had no idea how much work it was going to be. At GitHub, we had rolled our own multiple database setup years ago. We monkey patched Active Record, we added custom methods for establishing connections, we wrote our own custom Rails tasks. We had hacks on hacks on hacks on hacks to make migrations work, connection swapping work, and an around filter for auto swapping connections. Since I hadn't written any of the functionality we had at GitHub, I couldn't just go straight to upstreaming our hacks. I needed to figure out what Rails was missing and what features we actually needed. Just because it was in GitHub didn't mean it was necessary to implement in Rails. I implemented multiple databases on a brand new application to see what the user experience was really like. And it didn't take long to figure out that even basic functionality was missing. And I quickly discovered that migrations were completely broken. There was no way to change the connection a migration was running on. There was 3-level config support for multiple databases per environment, but the feature wasn't parsing the configurations correctly, and using this feature would cause an application to fail to boot. There were no Rails tasks for creating, deleting, migrating, or operating on more than one database per environment. Beyond missing the basics that make Rails enjoyable, there was no way to establish more than one connection per class. There was no support for roles or shards or replicas. And lastly, there was no API or pattern for automatic switching. In situations like this, it's easy to get overwhelmed, and I'd be lying to you if I said I never got frustrated or angry or unsure of the right way to fix something. And I wasn't the first person who tried to add first-class support for multiple databases to Rails. There were a bunch of gems that do similar work, and we had tried over the years to make it a priority on Rails core. However, we'd often get hung up on the perfect API and how to fix the internals without breaking public APIs. I knew this was going to be a big project, so instead of trying to fix it all at once, I broke the problem into features that were needed to make multiple databases in Rails not just functional, but a positive user experience. First, we fixed migrations to know about migrations paths and have a context to the connection. We turned configurations into objects. We made Rails tasks functional. We added connection APIs. We fixed a lot of internals and eventually built a sharding API. Then we implemented an API pattern for automatic swapping. There's a lot of work left to do, but we've accomplished a lot in 2.5 years. If we looked closer at the timeline and actually looked at each of these pull requests, you'd be able to see that from January 2018 to June 2019, the majority of the work done to Rails was actually just on the public API. I heavily focused on application and user experience to ensure a smooth and easy to use feature. If I had rewritten internals without knowing the user experience or APIs, then we'd end up either trying to fit the API into work we'd done or churning internal code over and over again. For the later half of 2019 into this year, we focused mostly on private APIs and internals. A lot of this work was to fix bugs or inconsistencies in the non-public facing code. We removed undocumented classes. Shopify rewrote the PID tracker to be more modern, actor support fork tracker. We converted hash lookups to use the database configuration objects. My approach to fixing the public API first and then working inwards is a bit unique. As software engineers, we want to anticipate everyone's needs and future use cases and try to fix all the broken things first. We want to build the most resilient and most perfect software. But to do that, we have to have a strong foundation, right? What if I told you that Rails already has a strong foundation? It's already strong enough. It wouldn't have been possible for me to build these public APIs first if that wasn't true. Rails foundation is why applications that start on Rails can grow on Rails, as long as we keep working on improving that foundation. Rails keeps your applications simple and less complex because it takes on much of that complexity for you. We built Rails as a strong foundation to support your applications as they grow from Rails new into an application that serves millions of requests and stores terabytes of data. The majority of Rails functionality has been extracted from real applications running in production. This is what makes Rails so stable. We build Rails to support your applications. We don't build Rails for perfect imaginary use cases. Building for perfect use cases doesn't work when you have to support public, widely used APIs. When we're building for open source, we're not building for ourselves or our company or our product. We are building for everyone, for all of you. It would have been selfish for me to rewrite connection management to be what I thought would be perfect without considering your needs. When building open source tools, you must consider what public APIs might break, what use cases you're not considering. You must be flexible enough to change course when your plans don't work out, but not so flexible that features never ship due to scope creep or strive for perfection. Finding this balance is really difficult, but essential to supporting an open source framework. When we build features for Rails, we don't build features for ourselves or our egos or our needs. We build Rails for you. We built multiple databases for you. Rails is truly unique. Even if you think Rails has too many features, or you don't agree with the APIs, or you don't like how we run the community, you'd be hard-pressed to find any framework that cares more about you than Rails. We actually optimize for programmer happiness. How many languages or frameworks in the world can say they actually care about you? Without this, Rails would just be another framework. Most frameworks care about bytes and widgets and other interpersonal things, while Rails actually cares about you. Not in the sense that it's sentient, but it's built with your experience as a person in mind. Rails cares about your applications, your company, and you. When I give presentations, I usually ask the audience to do something for me. In the past talks, I've asked you to look at your applications for technical debt you can upstream to Rails, or I've asked you to upgrade your application so that we can continue to support Rails for the long term. But for this talk, I only want you to know how much it means to me that you are all a part of Rails and a part of this community, and I am grateful for all of you. This timeline in this talk isn't just a visual representation of the work that went into multiple databases. It's a visual representation of my love of Rails in this community. So while this was technically a talk, it's actually a love letter. Regardless of your role, whether you're a user, bug reporter, contributor, multiple databases is a success because of you. Rails is a success because of you. Your success is my success. Thank you for letting me share this work with you. Okay, we're done. I don't know what the next thing is.
Here I am. Don't worry about it. Eileen, you can read in the chat how much people appreciate and love you back, the work you have done together with your colleagues. We are extremely grateful. I think I can speak for everyone when I say this, because one of the reasons why we are still able to use Ruby and to use Rails in our daily job is because you are putting so much effort and so much thought into it. Actually, one of the things that really strikes me is how exactly you have followed this path from outwards in, exactly for like keeping the users in mind. We are the users, and that makes everything a great experience to work with Rails. So thank you again. We have a couple of questions if you are open for it.
Yep.
There was a question regarding asking if multiple databases as a feature is available only from Rails 6 on. I assume it is.
Yep. Yeah, it's only available on 6 plus. That's just because of when it got built, and we don't. So we don't backport features to any released version. So 5.2 is already out when I started the work, or was released shortly after. The migrations contexts work is in 5.2, but nothing else is. So you can't actually really do anything.
Yeah, I think the question was like, it's so cool if you happen to know about tools that can potentially help people in older versions of Rails to use the feature. That would be useful information to have.
Yeah. My advice is to upgrade and then use it, because staying like 5.2 is going to be not supported soon.
Yeah.
So I know that upgrades are hard. I've done a lot of them. If anybody wants to see the GitHub upgrade, I have a talk about that from last year. So
remember.
I know that they're hard, but like putting them off just makes them harder. So
exactly.
But there are gems. It's just the thing is like the gems aren't compatible with the way we wrote the Rails features. So like even if you use the Octopus gem, converting then over to Rails multiple databases I don't know anyone who's done that conversion.
Okay. Thank you.
So if you need the feature, it's better to upgrade than to like implement something from another gem and then try to upgrade, and then it could get messy.
I mean, in the end, you're just postponing the issue, and you are actually doing twice the work in terms of time and effort, without the deep advantage of also upgrading for all the other things that you get with an upgrade. There were two other questions. One was about, is it possible for Active Record to automatically use the replica for select queries and primary for other queries as an alternative to the connection swapping middleware?
Yeah, we considered that, but the thing is, there is no way for like Active Record to calculate the replication lag. So the reason that we did it in the request type is because then you could, so like that's actually how we do it. Well, we do that at GitHub, and then we also actually use GTIDs. So we probably will upstream GTID support, but that's sort of like a later thing. I think we're still sort of figuring some of it out, like how it works for us. And so like on the like query level, there's no way for Active Record to say, okay, is it actually safe for me to read from the replicas? And so because if you're, say like something happens to your replicas and there's like a 5-second lag, you don't want to be sending everyone to your replicas and not have like no way to turn that off. So the request thing is like a little better because we can guarantee that when like at least on GitHub, this is how it works. When you write to the database, so you open an issue, we guarantee that you will be able to see that issue immediately. If there was happened to be like a second of lag, which is almost never happens, all other users in the world wouldn't be able to see that issue until it got copied over in that 1 second. But usually it's so fast that no one even notices. It's not like you make an issue and then someone in sub-seconds can see that they can't see it yet. So yeah, it's not really feasible to do on the Active Records like SQL level. But with GTID support, you're doing less with that. So that's maybe coming in the future. I don't want to make promises though.
Thank you. The second question is this feature suited for multi-tenancy?
Yeah, that's the sharding side is multi-tenancy.
Yeah.
There's so many names for it that like I couldn't fit them all in. I was like, someone will figure out that. So when I say sharding, I mean multi-tenancy.
Okay.
The sharding support is still a little new. There's no automatic switching for that. So you would have to write your own around filters. It's not super complex. Like Zendesk actually has a multiple database gem that already like has something like this that I think we're gonna maybe borrow from. I don't know. We don't actually use the sharding API at GitHub, so it's harder for us to like keep implementing features on it without input from the rest of their users. Yeah. So if you're using it and you have input, let me know.
Yeah, of course. Okay. Thank you so much then, and see you later.
Yep. Thank you. Thanks, everybody.
Bye.